This is the second video in Exponent Properties, and I want to remind you that I'm using A, B, and C here to represent unique numbers to generalize this case for all possible number values. So the next property I want to go over is if you have two numbers being divided, like A and B, and then the whole entire thing is being raised to a power, you simply put the power on both of the numbers. That's what the rule says. So in this case, if it was a over b to the c power, the entire thing to the c power, that's just a to the c over b to the c. So let's show why that is using a real number. So let's let c equal 3 for this case. So if we have a over b to the third power, that just means a over b times a over b times a over b. And we don't need to keep these parentheses. It's all just multiplication. So we can drop the parentheses and say, okay, well, that's a over b times a over b times a over b. Now, this is fraction multiplication. We don't need a common denominator. We don't need to do anything. All we need to do is just multiply the numerators together and multiply the denominators together. So we can rewrite this as a times a times a over, let's move this up a little, over b times b times b. And what is b times b times b? Well, that's b cubed, and a times a times a is a cubed. So we have a cubed over b cubed. And so you see it's just like taking the exponent and putting on both of the numbers in the ratio. Okay, let's look at another property. This is a little simpler. And the property is just that when you have any number represented here by a and raised to the first power, that's just itself. That's just the number. So, for example, 3 to the first power, well, it's just 3. Why? Well, if it was a squared, it would be a times a, right? But this is just a to the first, just one a. It's not multiplied by anything else. You could think of it as being multiplied by the number 1, but that's just still a, right? And so any number to the first power is just that number. Now another property that's really important is actually if you have some number raised to the 0th power. Now that might look a little weird. And what this means is any number raised to the 0th power is just 1. It doesn't matter what the number is. It's always just 1. Now, how does that work? Well, the best way I can show this is if we have some exponents that we know what they equal. So for example, we know what a cubed equals. That's a times a times a. And if we decrease the power by 1, so then we go down and we see, okay, what happens when we decrease the power by 1 and we go to a squared? Well, that's a times a. If you look between a cubed and a squared, we lose an a. And it's almost like if you were to divide by a here, you would cross one of these out, right? And you would get to a squared. And so, again, if we go to a to the first, we said just a second ago that that's just a. Again, we see this pattern. And it's almost like we took a squared, divided it by a, right? And that took us to, we were just left with an a here. So then, using that same exact logic, if we look at a to the 0, so we decrease the power just by 1, well, if we go up to a to the first, we divide by a. We get a over a. That's some number divided by itself. Well, that's always 1. It doesn't matter if a was 100. If you have 100 over 100, it's still 1. If you have 99.5 over 99.5, it's still 1. It doesn't matter what the number is. Anything to the 0th power is always just equal to 1. The only exception to that rule is if you have 0 to the 0th power. I believe we can say that this is undefined. Now, I might not have that terminology perfectly correct. It might be indeterminate. I can't remember if it's indeterminate or undefined. It might be indeterminate. In either case, we don't have an answer for that. So that's just the one case you got to watch out for. But for every other possible case, it's always 1. Okay, so the next rule, actually, we can build off of that. What if you have a to -1. So now we're talking about negative exponents. If we use the same sort of reasoning we did here to prove a to the 0, well, again, if we took the previous exponent, we decreased by 1. It's like if we were to divide by a. Well, if you have 1 and you divide by a, we see it's just 1 over a. So a, any number to the -1 power is just 1 over that number. It's like taking the reciprocal. So for example, if you had 5 to the -1, that's just 1/5. If you had 100 to the -1, that's just 1 over 100. And I just said something earlier, said if we take the reciprocal, that's like taking something to the -1 power. So that also works for fractions. If you have 1/5 and that whole thing to the -1, take the reciprocal of that. That's 5. So you can think of it a couple ways. One is it's just 1 over the number, or you can think of it as being taking the reciprocal, which is actually the same thing. And so those are all the exponent properties that I wanted to cover, and we will do some problems with these and try to actually get a good handling on how to apply all of these rules that we covered in these videos. See you in the next one.